Here's another example of a differentiation I want you to do using the quotient rule. So you know what to do now. Pause the video and go ahead with it. Alright, good. You have paused the video and you have completed this differentiation. Let's go through it. dy by dx is equal to, so you know what to do. You hold the denominator, you hold the bottom, x squared minus 4 times differentiate the top, d by dx of e to the 6x minus hold the top, e to the 6x times differentiate the bottom, d by dx of x squared minus 4 all over the bottom square, denominator squared, x squared minus 4 squared. Now x squared minus 4 d by dx of 6x, what is this? When you differentiate, let me rewrite this 6 here, it looks a bit messy. When you differentiate e to the 6x, what do you get? Well, what you have is e to the 6x. You have a function of another function. Use the chain rule. So, without rewriting the dy by du times du by dx and so on, once you develop the skill, enough skills in differentiating using the chain rule, you can see what's going on without too much writing. So let's go. You have e to the 6x. It's like e to the u. So you say this one function is e to something. You know that when you differentiate e to something, you get e to that same thing. So it's e to the 6x. Then this is the inside function. You differentiate this with respect to x. When you differentiate 6x, you get 6. So you multiply this by 6. Alright? So it is 6e to the 6x. Alright, so continue. Minus. You hold e to the 6x as it is. Differentiate x squared minus 4. You know you get 2x when you do that. All over x squared minus 4 squared. You could keep this as it is, or you could expand it out. It's x squared minus 4 by x squared minus 4. So you have, alright, let me erase what we were doing earlier here. So what you have now is x squared minus 4 times 6e to the 6x. Let's put this in front. 6e to the 6x times x squared minus 4 minus, this is 2x e to the 6x, and this is all over, and you can multiply this out if you want. Right? So what you will have is x to the 4th minus 4x squared minus 4x squared. That's going to be minus 8x squared plus 4 16. Right? So that's one way you could finish it off. Another way you could consider doing it what you could do is keep the x squared minus 4 squared, and you could divide or multiply both top and bottom by 1 over x squared minus 4. Alright? In other words, you divide the top and bottom by x squared minus 4. This x squared minus 4 will be over x squared minus 4, and what you will get it, you will get it you get it cancelled, and you have 6e to the 6x minus, then you'd have 2x e to the 6x over x squared minus 4, and all of that will be over x squared minus 4 without the square, right? You could also have them separated. So what you could do, if you divide this by both top and bottom by x squared minus 4, or consider this written in this way, x squared minus 4 over x squared minus 4 squared, 6e to the 6x minus, and then this would be 2x e to the 6x over x squared minus 4 squared. This would cancel, and you would end up with this, right? 6e to the 6x over x squared minus 4. So whichever way you want to finish it off. Sometimes in a multiple choice question, they will ask you to differentiate this function, and then they will say A is in this form, B it is in that form, but when you differentiate it, it doesn't look like any of them. But if you make some changes, you'd have your answer looking like the one in A, the one in B, C, or D. Alright? Although multiple choice questions don't usually have differentiation as long and complicated as this one, right? But you'll find this type of differentiation in the written part of an exam. Alright, so just a quick review. As you see, you hold this x squared minus 4, differentiate the top here, minus, hold the top, e to the 6x, differentiate the bottom part, over x squared minus 4 all squared. So this is x squared minus 4 times 6e to the 6x minus, we keep e to the 6x as it is, then differentiate this and you get 2x over x squared minus 4 squared. And of course you put the 6e to the 6x in front as is customary, and put the 2x in front to get 2x e to the 6x as is customary. Alright, so I'll see you in the next video.